Hello Year 11, welcome to our first online lesson. Today we're going to have a look at angles of any magnitude. So here's our heading, angles of any magnitude. Now what this means is we're going to learn to take the sine and cosine and the tan of angles that are bigger than 90 degrees. So how is that possible? Well, we know things like sine of 30, and pause your videos and see if you can think of what sine of 30 degrees actually is. Okay, you know it's a half, and that's of course because if you have a right angle triangle like so, if this is 30 degrees, you know that that would be 1 or that'd be 2. Or, the opposite would be 2, the hypotenuse would be 4, and it would follow that ratio. But we can actually take angles of, or sines and cosines of much larger angles. So we could take a sine of 150 degrees and also get a half. We could take a cos of 2000 degrees and also get some number. I'll let you put that into your calculators and see what comes out. So the question is, why is this? If sine, cosine and tan are defined as ratios of sides inside a triangle, how can I take a sine, cosine and tan of some angle which is bigger than any angle I can reasonably fit in the triangle? So let's take a look at a new definition of sine, cosine, and tan. And we're going to start off just with a basic coordinate axis. So there it is, my y-axis and my x-axis. And on this coordinate axis, we're going to draw the equation x squared plus y squared equals to 1, and I want you to pause this video for a second and try to draw whatever figure this is before you watch me draw it, just as a bit of curve sketching practice. Done? Okay, good. So of course you know it's a circle, and this may not be the best circle, but hopefully that's circly enough. Now this is a 1, this is a 1, this is -1, and this is -1. And what we're going to do is we're going to draw a triangle just in the first quadrant of our circle. So here's the first quadrant, and we're going to draw the hypotenuse of a right angle triangle reaching out to here. Here's a point on the circumference. This can be some angle theta, like so, and I'm going to put my opposite side down here and my adjacent side along here, and this is a right angle. And let's just let this adjacent side be x and this opposite side be y. So now over here, let's work out what cos theta is. So cos of theta equals to, well, we know it's going to be, let me get my laser pointer, the adjacent over the hypotenuse. So that's just x over 1, and we know it's 1 because our hypotenuse is 1. So it's just x over 1, and of course we know that x equals to cos theta, just multiplying both sides by 1, I guess. And we're going to do the same thing for y. Let's just put it down here. So we know that sine of theta, hopefully that's readable, is y over 1. So we know that y equals to sine of theta. But wait a second. I also know that the x-coordinate of this point is just whatever this x value is, and the y-coordinate of this point is just whatever the y value is. So let's label on our x and y coordinates now, and we can see that this point here is just, still got my laser pointer on, is just cos theta cos theta for the x-coordinate and sine theta for the y-coordinate. And this is how we actually define our sine and cosine. We define our sine and cosine as the y-coordinate and the x-coordinates on the circumference of our circle, x squared plus y squared equals 1, when I'm measuring from the positive direction of the x-axis. One thing to note is this doesn't break our old definition of sine and cosine. This definition still fits perfectly, with sine being opposite over hypotenuse and cos being adjacent over hypotenuse. So let's now see if we can look at these quadrants in a little bit more detail. So I'm just going to create a new page here, which will take me a moment to figure out how to do. Not like that. Maybe this button. Nope, that button does the same thing. And there it is, created a new page, and that's just copied my old page. But let's erase this and go to my new page. Probably didn't even need to make a new page for this. So, hold on while we erase this, and then we'll be drawing up our unit circle again. So, the circle is now back, and you can see there's still a few smudges on the whiteboard, just like a real whiteboard. And here's my unit circle again, and here it is. There's my unit circle. And we know that this is the first quadrant, this is the second, this one's the third, and hang on, my pen, no, there it goes. This one's the third, and this quadrant is the fourth. So let's take a look at what sine theta quadrant. I know that my computer is lagging a little bit, but let's see how it goes. This point here. So I know that my cos theta is going to be positive because it's a positive x value, and my sine theta is going to be positive because the y value is positive. So I'm going to say A. All of them are positive here. Let's now jump to our second quadrant, and looking at this one, well, I know that sine theta is positive because it's a positive y value, but cos is going to be negative because it's a negative x value. So only sine theta is positive. So I'm just going to label this with an S for sine. I'm going to skip the third quadrant for a sec and look at my fourth quadrant. Well, my cos theta is positive because I've got a positive x value, this being the x-axis obviously, but my sine theta is negative because I've got negative y values, so only cos theta, C for cos. And now back to my third quadrant. Well, theta and cos theta are negative down in this quadrant, but I do know something that's going to be positive here, and that's tan theta. And the reason that tan theta is going to be positive is because I know that tan theta equals to sine theta over cos theta, and a negative over a negative is a positive. And we've got our helpful little device to help us remember this. And my computer's lagging again. A, S, T, C, all stations to central. I'm sure you can think of your own little acronyms or initialisms or whatever to help you remember those. Alright, so now we've done this, let's see if we can solve a few problems using our unit circle. And I'm going to ask you for some exact values, and I want you to pause the video and actually try to work these out before we do them. So let's first of all do cosine of, let's do 135 degrees. And how am I going to do that? First of all, I'm going to draw up my unit circle again, and here it is. and I'm going to be measuring 135 degrees from the positive direction of the x-axis. So that's over here like this. And when I say I'm measuring 135 degrees, I'm measuring it from here. So that's 35 degrees. Hopefully you can read that. And that's of course 45 degrees. And I'm making this little triangle in the second quadrant, the sine quadrant. So here's another 45 degrees. But if I know that this is 1, well, I know my exact value triangles. I know I've got this one here and this one here. So I've got 1 on root 2, 1 on root 2, and 1, and the angles are 45 degrees. So I know cos of 135 degrees is just going to be the x value in here, which is going to be, well, I'm going to say 1 on root 2, but since x is negative, it's negative 1 on root 2. And while I'm at it, the sine value is just going to be 1 on root 2. And that's the coordinates, negative 1 on root 2, 1 on root 2. So cos of 135 degrees is minus 1 on root 2. Okay, second example. As soon as I can find my first, and let's erase this. And we'll try a slightly trickier one because we'll go backwards. And let's now try a tan, and let's work out what tan of negative 150 degrees is. Alright, so you can pause the video and have a go at that. I'll also have a go here. So negative tan, or tan of negative 150 degrees. So hopefully you're used to seeing our little unit circle now. Now, because it's a negative angle, it means instead of starting here, clockwise around, we're going to go anti-clockwise. So here's 0, here's negative 90, and here's negative 150. And you can see I've actually right back into the tan quadrant. So it's going to be about here, and I can change the color of the ink I'm using. So we know that this part is going to be 150. It's negative, and of course this part here is going to be 30 degrees, and it's negative 150. I'm moving clockwise. So here's my little triangle, and I'll just draw another version of it here. And it's a 30, 60, 90 triangle. So 30 right angle, 60 and 90. And of course I've got 2, root 3 and 1. So here's my triangle down here, and let's color it in. So this is the triangle that I'm looking at, and I've drawn a bigger version on the side for you. So I'm now doing tan of this, and I'm going, well, tan of 150 degrees, it's like taking the tan of 30 degrees because I'm working in this triangle, and the opposite side is of course going to be here, and the adjacent side's here. Notice that this isn't this side here, which I'll laser point is anymore. This isn't actually root 3 because I've made this 1. So I've actually halved everything because I've put it inside the unit circle. So I guess we could say, where's my, here, we could say this is a half, this is 1, and this is root 3 over 2, because I've fixed the radius to 1, but the ratio is still the same. So tan of 150, it's like tan of 30, but is it positive or negative? Well, let's think about it. A, S, T, and C. Well, tan's positive, so we're just like at positive tan 30. So the answer is 1 on root 3. I hope you got that one right. Okay. Third example, let's just turn on the eraser. And we're going to this time do a more general one. And in fact, let's do 2 more general questions just for fun. So the first one I'm going to do is I'm going to ask you what question 1 can be cos of 180 minus theta. Question 2 can be sine of 180 plus theta, and question 3 can be a slightly more challenging one. It's going to be cos of 90 plus theta. We can derive formulas for all of these, but really it's not worth memorizing all of these if you understand how to derive them. So let's go to our unit circle again, and here's a nice unit circle for us. And give me a second. We're going to draw this one on here like so, and like this. Okay, so cos of 180 minus theta. So I know here's my 0, here's my 90, here's my 180, and since I'm going back by theta, it's going to be a theta will be there, and a 180 minus theta will be here. So I also notice I'm in the sine quadrant. So cos of 180 minus theta, I'm basically just asking for this x value here, right? Because I've got cos of 180 minus theta is my x value, and sine of 180 minus theta. But I know that this is just going to be the same as cos of theta, because if I put a theta here, and let's really make a mess on this, if I was to put a theta here like this, well, there's a theta. We can see that these are pretty much symmetrical. They'll have the same x value, so it's the same as regular old cos of theta, but cos is negative because we're in the sine quadrant, or we can just see cos is negative, so boom, cos is negative, so cos of 180 theta is same as minus cos theta. Alright, let's try another one now. Let's just erase this and touch up our board slightly. So here's my unit circle back again. Sine of 180 plus theta. Pretty easy. So here's my theta. Obviously this is 180 plus theta. There's 180 and there's theta. So we're looking at this triangle in here. So the sine of this is basically we're looking at the y-coordinate of this, because the x-coordinate of this is 100 plus theta, and the y-coordinate of this is, sorry, yeah, that's right, sine of 180 plus theta. So it's basically just going to be the same as sine theta, because if I do sine theta, here's a theta here, these are two congruent triangles, you know that this is going to be sine of theta. This will be sine of 180 plus theta side, which I'm highlighting here. And this side are the same distance, but one's positive and one's negative, so it's going to be negative sine theta. Let's just change the color of the pen there, and that's equals to negative sine of theta. All right, final one. Let's now do our this. And cos of 90 plus theta. You've probably realized that I've been going from the horizontal axis, the x-axis previously, but now I'm going to be going from the y-axis. So this is my theta, and here's my theta, and I'm looking for cos of 90 plus theta. So here's my triangle like this, but what I'm going to do is I'm actually interested or more interested in this point here. So I'm going to again draw a second triangle measuring from the horizontal, and there it is. Now we've got our point here, and you can see, so this point here is 90 minus theta. So let's put a 90 minus theta now. So 90 minus theta, and we're doing cos of 90 plus theta. So I am looking for this x value here, this x value here, cos of 90 plus theta. So pause the video and have a think about if you can work that out. Alright, hopefully you've paused it and had a go. So what we're going to do is we're going to first of all observe that we're in, so whatever answer we get is going to be negative, so it'll be negative something, but the question is negative what? And hopefully you guys can see that this one here, I'm looking for this x coordinate here. It's going to go back to my highlighter for a second. I'm looking here, and you can see it's a negative x coordinate, and it's given by this side here. And let's even label it x. So that's an x. And I've got my right angle triangle here, and if I've got a 90 minus theta there, I've got a theta here. So now I can say, well, okay then, sine of theta equals to x over 1. Sine of theta equals to x over 1. So x equals to sine of theta, and I now have my value of minus sine of theta. Okay, there we go, guys. I will stop there, and I'll upload another lesson soon. You've got the